Welcome back. Today we're going to talk about section 3.2 and we are going to discuss the concept of slope. Okay? Slope. What is slope in your own words? Well, many of you guys will talk about slope and say, well, slope, that's easy. Slope is rise over run. Okay? Or you'll say slope is M. Well, I'm not sure what that means, but you could do that. There is a portion of algebra where slope is m, okay? But slope is really, it's a rate of change. It's a steepness. Visually, certainly it's a steepness. But a rate of change is how we generally try and define slope. How quickly something changes over time or some other type of concept, okay? A rate of pay, how much you get paid, is a rate of change. There's a steepness or a slope in terms of earning money. How fast you run or how fast you drive. Those are all rates of change. So how quickly something changes. Okay, so slope on the coordinate plane, on the Cartesian plane, slope, a positive slope would be something that as you read going from left to right, that purple line has a positive slope. So it's rising as you read from left to right. That would be a positive slope. Something with a negative slope, well, again, as you read from left to right, it is going down. Okay? So here we have, the red line is something that has a negative slope. That particular line has a negative slope because they're going down as we proceed from left to right. They seem to be going down. Okay? So slope. Algebraically, we define slope. Yes, M. You'll see that in one of our formats for slope. Slope is rise over run. Okay? If we have two ordered pairs, let's say we have two ordered pairs, x1, y1, and another ordered pair, x2, y2, we can calculate slope by subtracting one of the y coordinates from the other and dividing it by the difference of one of the x coordinates from the other. Be careful with y2 and y1. If we start with y2, if we start with this ordered pair on the right-hand side, we take y2 minus y1, we get to go back to that same ordered pair, x2 minus x1. So that's really all those subscripts mean. It means if we start with the y coordinate of one ordered pair, we have to use the x coordinate of that ordered pair in the same spot. Okay, so we couldn't use x1 down here minus y1. We wouldn't get the correct slope. So, and then another way you'll see slope written is this change in y divided by change in x. And that triangle, I think we've seen this before, that is just kind of a symbol for change. So delta or change. Change in y over change in x. Again, slope is rise over run. Rise is y's, so we have the y's on top, so we rise to the top. So we always know y's divided by x's. So given two ordered pairs, we can always calculate our slope. And simply taking our y coordinate and subtracting one from the other. So starting with our y's, I take negative 5 minus 9. So let's go ahead, y2 minus y1 over x2 minus x1. So negative 5 minus 9, all divided by 3. I got to go back to that same ordered pair. 3 minus a minus 6. So in calculating our slope, negative 5 minus 9, that would be negative 14 divided by 3 plus 6, which is 9. So our slope, negative 14 ninths. Well, one of the things that sometimes we get confused about is the slope of a horizontal line versus a slope of a vertical line. Okay, so let's take a look at this visually. Let's look at our horizontal line. Horizontal line, okay, straight line, something like that. So think about a roller coaster. If we're on a roller coaster and it's just going just along, flat along the ground like this, moving straight, no pitch at all, should be careful with that, but just along no hills or anything, that's not much fun. That is zero fun. That is not a lot of fun. So let's say we're on a roller coaster. Now we got something that has a little bit of pitch to it. That's a little bit more fun, isn't it? That's more fun. Okay, so now we're going downhill, so we're a little bit more fun. How about if it gets a little steeper? Wow, that's even more fun. Wow, I really like that. That is more fun. Okay, I'm really excited. I'm enjoying that. That's steep. That's thrilling, kind of fun. But now, what if I just go drop straight down like that? How fun is that? Now my roller coaster, just a vertical line. I'm going straight down. That's an indescribable amount of fun. Undefined fun. I had so much fun I can't even define it. So you can see here, as we go through, as our roller coaster goes from something that's just flat and horizontal, not a lot of fun, but as it gets more and more vertical, tougher and tougher to describe, now we've got an undefined amount of fun. So now we know if we have a line that's perfectly vertical like that, okay, so say that might be, I think that's x is negative 7. That particular line is an undefined amount of fun. That is an undefined slope. While the graph of a horizontal line, that's y equals 3. Okay? Well, that's zero fun. That's not too much fun. Zero fun. That's a little better, not jumping around. So that is zero fun. Okay? And you'll also see this undefined slope. You'll talk about that. That is no slope. Okay, but I don't like using no slope too much. That's algebraically, that's correct to say no slope for undefined, but we often confuse no or none with zero, and they're not the same. So I prefer undefined versus zero. And how does this look mathematically? How does that work? Well, rise over run, that's our change in y over our change in x. So let's take a look at our equation here. At y equals 3, our blue line, well, if y is always 3, is there any change in y? No, there isn't. Y is always 3, so there's no change in y. So we have 0 over, now we could have a bunch of change in x, some particular number. 0 divided by a number, well, that is 0. Whereas if we have the equation x equals negative 7, well, our slope, to calculate slope, change in y over change in x, okay? Let's take a look at that. Change in x is always negative 7. Well, doesn't matter what y is, x is always negative 7, so our change in x is 0. We're going to have some number on the top. Well, 0 is underneath, so that particular slope is undefined. So, sure enough, x, a vertical line, has an undefined slope. because there is 0 change in x, and we have 0 in the denominator of our slope equation, and so that makes a lot of sense. So the sooner you can, recognize the difference between 0 slope and undefined slope, and realize that 0 in the numerator is 0, 0 underneath in the denominator is undefined, the better your math career is going to go. And the final thing for this video, we're going to take a look at converting something from standard form into slope-intercept form. So we're going to take this particular equation. Let's take standard form where a, b, and c are all integers, and let's solve this for y, and let's see what we get. So I want to solve for y, so I'm going to go ahead and I'm going to subtract ax from both sides. Okay, so once I do that, now I have by equals negative ax plus c. Well, I haven't solved for y yet. I've got by here. So I have to divide every single term by b. And I get y equals the opposite of a over bx plus c over b. Okay. Well, we haven't talked about slope-intercept form, but I know you guys have seen slope-intercept form in the past. And slope-intercept form is y equals mx plus b, where m, or the coefficient on x, is the slope, and b, or 0b, is our y-intercept. So if we go back and take a look now at our y equals negative abx plus c over b, well, sure enough, negative a over b is the same as m. It's in the same location as the coefficient on x. And c over b is going to be some constant. So as it turns out, in standard form, slope is the opposite of a over b. So let me show you why. Again, now let's do something with numbers. 3x minus 4y equals 12. So we put numbers in for a and b. Now let's go ahead and solve for y. So I'm going to subtract 3x from both sides. We get negative 4y equals negative 3x plus 12. I haven't solved for y yet. I got to divide by negative 4. Be careful. So when I get y equals negative 3x over negative 4, that's 3/4 minus 3/4 x minus 3. So now we're in slope-intercept form, and you guys would tell me the slope is 3/4. Well, didn't we know back here at the beginning that a was 3 and b was negative 4? Well, if slope is the opposite of a over b, if we're in standard form, the opposite of a is negative 3, and the opposite of b, and just b, is negative 4. So our slope, negative a over b, is the opposite of 3 over negative 4, which is 3/4. So if the slope of our line is 3/4, well, we can get it by writing it into slope-intercept form and seeing what m is, seeing what the coefficient on x is. Or, if we're really paying attention, we can look at our a value and our b value and take the opposite of a over b, the opposite of a over b, the opposite of 3 over negative 4, and just eyeball our slope and know that it is 3/4.